Hello and welcome back to our math lesson. Our math lesson today, as you can see, is going to be lesson 9.4. If you could write this down. Measures of variation. What does measures of variation mean? It means the measure that describes the distribution of a data set. So I'm going to give you some time to go ahead and write that in your notes. I'm going to be explaining to you exactly what that means, distribution of a data set. You probably are very familiar with the next term that I'm going to give you, and that is the word range. The range is the difference of the greatest value and the least value. All right, so here's our definition, if you want to write that down. Please remember you can always pause the video if I'm going a little too fast for you today. All right, well, let me show you an example of what I'm talking about when I'm talking about the range. In our book on page 434, we have an example of how to find the range. It says here that the table shows the lengths of several Burmese pythons captured for a study. Find and interpret the range of the lengths. To find the least and the greatest values, order the lengths from least to greatest. So that was been done for us. The least value is 5, and the greatest value is 18 5/10. So in order to find the range, we do the difference, which would be subtracting. We would subtract 5 from 18 5/10, and we would find out that the range is 13 5 feet. This means that the lengths vary, and that's what we mean by distribution of data. It varies by no more than 13 5 feet. So the numbers over here, there's a difference from the least to the greatest of 13 5 feet. What I would like for you to do in your notes is I would like for you to answer the try it. The ages of people in line for a roller coaster are 15, 17, 21, 32, 41, 30, 25, 56, 16, 39, 11, and 24. Find and interpret the range of the ages. If you would please write that in your notebook for me. Not this problem, just the answer. Most of you probably have looked and found that it looks like 11 is our smallest or least value, and 52 is our largest value. So in our notebook, we're going to take 52 minus 11, and we found out that we have a range of 41. Now, if you recall, the direction said to find, we found it, the range is 41, and interpret. Interpret means we write a statement, and the statement we're going to write is this one. So when I see the answer 41, I don't know what you're talking about. 41 what? Well, interpret means I'm going to explain to you what 41 means. 41 means the ages of people in line vary by no more than 41 years. So all the numbers we had listed, they vary from the largest number of 51 all the way down to 11. That's a difference of 41 years. So go ahead and copy this sentence down so you understand how to interpret the range. right, well, the next thing that we're going to move on to is something called quartiles. And you might have talked about this a little bit with your teacher as you were preparing for your IAR test. Quartiles, the definition is of a data set divided the data into 4 equal parts. So let's go ahead and write that down. All right, so there's our definition. Divide the data into 4 equal parts. So I'm going to give you a set of data that's already going to be in order from least to greatest. Remember, data is a set of numbers. All right, so the numbers we're going to write, there's going to be 10 of them. And I kind of tried to write small enough so I could fit them all in one line. 18, 21, 22, 24, 28, 30, 31, 32, 36, and 37. Now remember, the definition of a quartile is divided into 4 equal parts. So we're going to have to do a couple things here in order to find our 4 equal parts. The first thing we're going to do is we're going to find the median. Well, yesterday we learned that the median is the center or middle of the data. Well, if I know that I have 10 numbers, if I split 10 in half, that's going to be 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So my median is going to actually be right in between 28 and 30. There's 2 ways that I can find the median. One is I can look at the 2 numbers and I can determine what comes between 28 and 30. The other way is I can add the 2 numbers together and divide by 2, and my answer is going to be 29. Now you will notice that our median has split our data into 2 separate pieces, a lower half and an upper half. Our median can never be part of our 2 pieces. So if 29 was actually written right here, we would not count 29 as part of the half. So you will notice this is our lower half here. So I'm going to make a little thing like this to help us know that this is our lower half. And then this side over here is our upper half. Now, right now we only have 2 different pieces, and we said up here we need to make them into 4. So what we're going to do now is we're going to look at our lower half. I'm going to take this pencil and we'll just cross this off just to help us focus on what we need to. So I'm looking here at these numbers. Now I have to find the middle so I can cut it in half. There's 5 numbers, so I notice that my middle number is right here. It will be called 22. So we call that our first quartile. But we all know as mathematicians, we want to be fast and easy. So we call that Q1, and we found out that that equals the number 22. All right, let's go over here and do the upper half. Here are our numbers. Looks like they're 5, so our middle number here is going to be 32. This is called our third quartile. Or Q3. Q1, Q3. I bet you can figure out which one's Q2. You're correct. The median is also considered our quartile 2, but we don't ever really use that terminology. We always just call it the median. So now we have taken our data and we have divided it into 4 equal parts. Our lower half is divided into 2, and our upper half is divided into 2. The last vocabulary or terminology that I'm going to talk to you about is called interquartile range. Well, we already know what range means, right? Range means the biggest minus the smallest. Quartile. Well, we already know what quartile means. That means dividing into 4 equal parts. But we put the word interquartile. Inter means something that's closer to the inside. So we're going to look at our 2 quartiles. The interquartile range. Range means subtraction, right? The difference. We're going to do this. Our interquartile range is our 3rd quartile minus our 1st quartile, and that will give us what we call our IQR, interquartile range. So let's look up here in our problem, and let's see which one was our quartile 3. 32. What was our quartile 1? 22. 32 minus 22 is 10. So we found out that according to this data, our interquartile range is 10. Now, if you notice, interquartile range is from here to here. So this shows us the range of the middle half of the data, and it's just another way of measurement and variation. So the last thing I'd like to show you is basically something that is in your textbook. It's on page 435. Better light here. And it is also looking at the interquartile range. However, the data has been given to us in a dot plot. These are the speeds of 12 sports cars. And we have a speed from 220 all the way the range, all the way to 270. So what we did is we took the data value and we put them in order from least to greatest by listing all the dots. Notice that there's 230s. Put them in order. We found the median. Well, we know how to do that. You have to find the middle. Well, because there wasn't exactly, these 2 numbers were in the middle, we had to find the in between 245 and 250. We add them together, divided by 2. We found out that's our median. Once we find the median, remember, we're trying to find quartiles. I have to take my lower half and I have to divide it in 2. Well, there's 6 numbers. The middle is going to be right here. There is no number. Some of us know what comes between 230 and 240. Some of us have to solve 230 plus 240 divided by 2, and we found out our quartile 1. We did the exact same thing with our speeds from 250 to 270. Here's our middle, quartile 3. What comes between 250 and 260 is 255. If I'm going to find the interquartile range, you will notice that they took my Q3 minus my Q1, and they found out that the interquartile range has a difference of 20. This means that the middle half of the speeds vary by no more than 20 miles per hour. These two are 20 miles per hour, whereas you notice from 270 to 220, our range is going to be 50 miles per hour of a difference between all of our cars. Just wanted to show you that you can still make quartiles with dot plots by listing your numbers. Okay, you may go ahead and turn your video off and follow directions from your teacher.